Hey, good morning. Today, in the previous class, we have discussed about fuzzy commitment scheme. Is it visible, my slide? Fuzzy what?
Yes.
Okay. Fine. So in the previous class, we have discussed one crypto system, which is biometric based, called fuzzy commitment scheme. In fuzzy commitment, we have seen that if a secret is there, it can be encrypted using biometrics, and the ciphertext is in the form of HC and delta kind of thing. And after that, we can decrypt also if the almost same biometrics is given. Means intersection between the biometrics through which it was encrypted and the biometrics through which we want to decrypt have sufficient amount of intersection. Then it is possible. So that's why that scheme is suitable for most of the biometrics. Today we will discuss another scheme called fuzzy vault. So fuzzy vault construction is also based on the use of error correcting codes, whatever we have used in fuzzy commitment also, Reed-Solomon code. Or even in this scheme, we can also use CRC also, cyclic redundancy check, to detect the error actually. So, and through iteration, several iteration, it may possible to detect actually the error-free kind of cipher secret. So this is a cryptographic primitive whereby a user commits to a secret value, say S, under a key X. The user may decommit using any key X dash that is close to X under some suitable matrix. And maybe you can say X and X dash. The intersection is more than some threshold value. So an attacker without knowledge of the biometrics vector, a feature vector, that is X, cannot decommit and cannot find the secret. So suppose Alice wants to lock a secret S. S is our secret. Maybe any kind of secret length may also be any. But generally, or at the beginning when it was developed for managing the key of AES encryption scheme. In AES encryption scheme, the key size is 128 bit. So at the beginning, when it was developed by this Anil Kumar Chen and his team, and they implemented this for S, which is 128 bit binary sequence. So suppose Alice wants to lock a secret S under A. Under A means A is you can say the biometrics kind of thing. She selects a polynomial P in a single variable X such that P encodes in some way. So basically, the problem with biometrics is that is you can't have the same order of the sequence every time. Means the minutia point, if you consider the minutia point, you can't say this is always the first minutia point, the second minutia point, and so on. So ordering is the problem. So what can you do in that case? We can't use the systems which you have studied in cryptography course, maybe any block cipher or stream cipher or any asymmetric ecosystems, these can't be implemented using biometrics as a key, right? So what can we do is, if you select a polynomial p in a single variable x such that p encodes in some way, p encodes what? P encodes the secret s actually. So we are disguising p, we are disguising the secret s in p. So how it will done, we will discuss that. So Alice projects the elements of A onto the points lying on the polynomial P. Then Alice creates a number of random sharp points that do not lie on P. So some randomly generated points which are not lying on that polynomial. So this may be just like we are introducing noise actually. The entire collection of points, both these that lie on P and not lying on the polynomial P, we are calling them as the sharp points. They together constitute a vault. So this will be a bigger set. V is the set of points. Some of the points are lying on the polynomial, and there are some points which are not lying on the polynomial. Now suppose Bob wishes to unlock by means of set B. So now if suppose anyone wants to unlock, so the requirement will be to find out the polynomial, because the secret is lying with the polynomial. So finding reconstruction of the polynomial is possible only if sufficient number of points which are lying on the polynomial are known. And sufficient number of points lying on the polynomial means the points from the biometrics should be known. So if B overlaps substantially with A, it means it's the intersection of the set A. Set A is the set of points, just like minutia points of the biometrics, you can say. And B is also the set, that is the set of minutia points in case of fingerprint. So if intersection between A and B is greater than some threshold value, only then it will be possible to reconstruct that polynomial. Otherwise, reconstruction of the polynomial is not possible. Unless Bob can reconstruct the polynomial, it is also not possible to find out the secret. So B identifies many points in V that lie on P so that Bob can recover a set of points that is largely correct. So using error correction, Bob can reconstruct the polynomial P exactly and thereby can find the value of the secret S. Now, what is there actually? So if we have several points lying on the from the biometrics, means minutia point kind of thing. So we can have x comma y kind of points. So this we can convert into one coordinate. How can you do that? Just concatenate this y with x, and this is suppose equal to capital X. Now, suppose our secret is S, and secret may be say 4, 3, 2, 5. So what can you do is you can have a polynomial whose coefficients are this secret. So polynomial P may be in this case 4x power say, and after that you can also have one CRC kind of thing, and suppose CRC is something say 6 of these points actually. Then you can have this polynomial. This is 4 plus 3x power 3 plus 2x power 2 plus 5x plus 6. So this is the polynomial. So indirectly, this polynomial contains the secret basically. And suppose this is the graph of this polynomial. Here there is x and here there is px. This is the graph of this polynomial. Now, what can you do is you can project this x on this polynomial. It means for this particular value of x, you can find the value of p of x. So put this value of x in this polynomial, you will get something that is you are assuming as y. So that has to be a point on this polynomial. Is it clear? Because we are finding the value of y or px from this polynomial only. So that's why that will lie on this one. So in this way, you may be having x1, y1 corresponding value on the polynomial, x2, y2 corresponding value on the polynomial is y2 for x2. So in this way, there may be several such points. It is not necessary only for 5 points will be there. There may be many such points lying on this one. So apart from these points, you can have some more points. Suppose these are the points, and these points are not lying on the polynomial. We are calling these points which are not lying on the polynomial as the sharp points. And the genuine points are those which are lying on the polynomial. Now, if you give this set V, V is now the set of all those points which are lying on the polynomial and not lying on the polynomial. So this is a very big set. So if this set is given to anyone, the third person cannot construct the polynomial unless the person can find the points which are lying on the polynomial. The points which are lying on the polynomial are hardly say 20 or 30. But the points which are not lying on the polynomial are say millions or trillions. So it is a hard problem to find out the points which are lying on the polynomial from this set V actually. So unless one can find the points which are lying on the polynomial, not possible to reconstruct this polynomial. If it is not possible to reconstruct the polynomial, then it is also difficult to find out these coefficients also. So, and these coefficients are the secret basically. So indirectly what we are doing is only the authorized person whose biometrics matches with the biometrics which was originally used. It means if this intersection is equal to eta, which is say greater than equal to eta, eta is the threshold value. If this is there, it means how many points in this case are required? If we have 5 points lying on this polynomial, then we can reconstruct the polynomial of degree 4. So in this case, eta threshold is 5. So if 5 or more than 5 points are common in A and B in both of these biometrics, then it may be possible to reconstruct the polynomial. So indirectly, it will be possible to find out the secret also. So this is the basic idea behind this fuzzy wall. Is it clear now? If you have any question, any doubt, I have just given you overview about the fuzzy wall. Then why fuzzy wall? Due to overlapping. So due to biometric variance, conventional biometric system perform fuzzy comparisons by applying decision thresholds, which are set up based on score distribution between genuine and non-genuine points. If A and B overlap substantially, then the user can identify many points in the vault V that lies on the polynomials. So this I already explained you that if sufficient number of points are there, in this case, if this is the polynomial, then 5 points will be sufficient to reconstruct the polynomial. So the attacker or the genuine user has to find out these 5 points which are lying on the polynomial. And if the same biometrics is given, then it is easy to find out the points which are lying on this polynomial from this bigger set. Otherwise, it is a hard problem. So it is a sufficient number of points can be identified, and error correction scheme can be applied to exactly reconstruct, thereby decode the secret test. After finding the points, even then some error may be there because there may be some because of noise, and we know that the exact matching of the fingerprint minutia points is also not possible. So that's why some error correcting code or some error detection at least is required. Scheme is required. If A and B do not overlap substantially, it is infeasible to reconstruct the polynomial P, and authentication is unsuccessful in that case. Since the secret can be retrieved from the vault, even when they are not exactly the same, this scheme is referred as fuzzy vault. So that's why it is called the fuzzy vault. Because exact matching is also not required in this case. So indirectly here the key is the biometrics kind of thing. And the ciphertext is in this case is this one, set to V, vault. And secret is this one, secret. So this scheme is encrypting the secret using biometrics.
Sir?
So this, yes.
In the previous slide, wherein you were giving this example of 4325, sir, like I'm not able to understand like what will be the biometric here and what will be the secret. Will both the secret and biometrics be the same, or like I'm not sure here, sir, exactly.
No. Actually, suppose you have minutia points. Consider fingerprint biometrics, right?
Okay.
You can use this iris also, face also, any other biometrics also.
Okay, sir.
Consider fingerprint. So in fingerprint, what will you be having? You will be having x1, y1, x2, y2, x3, y3, x4, y4, xn, yn. These are the minutia points, suppose.
Okay.
Now, consider one minutia point, right? Say x, y. Then you find capital X. Capital X is what? Capital X is x coordinate of the minutia points, concatenate it with y coordinate of the minutia points. Suppose that is capital X. Okay. This is capital X. Now, suppose our secret is this thing. Secret is definitely maybe a binary sequence. So if it is a binary sequence, then you can convert it into byte. You can answer first byte, second byte, and third byte. Suppose these are the integers, corresponding integers, 4, 3, 2, 5.
Okay.
Then 6 is the CRC of that sequence, basically.
Okay.
Right? So, or any other error correcting, you can use Reed-Solomon code also here, right?
Okay.
Then the polynomial we have designed in such a way that these points, which are these values, which are secret, you can say, are the coefficients. So 4 is the first coefficient, then 3, then 2, then 5, and so on. So this is the polynomial.
Okay.
Right? So yes, polynomial is basically the secret, you can say.
Okay, fine.
Right? Now you have these points x1, y1, x2, y2, x3, y3. These are the points which are the biometrics, you can say, features or minutia points, right? Okay. Now it means you will be having capital X1, capital X2, capital X3, capital Y, and so on. So for X, capital X, if you use that value here, you can find P of capital X. Okay. Is it clear? You can find P of capital X. That is, we are assuming Y.
Okay.
Right?
Basically,
so Y is P of X.
So basically, using the secret, we are projecting the biometrics in some sense.
We are using the secret in the polynomial and we are projecting the points on that polynomial.
Yes, yeah. Fine. Yes, sir.
So okay. X1, capital Y1. This is a point definitely lying on this polynomial because we have got
Yes.
y1 from this polynomial only.
Yes, sir. Yes, sir.
So definitely x1, y1, x2, y2, all of these points will definitely lie on the polynomial only.
Okay.
This polynomial. Apart from these points, you can generate some random points which are not lying on the polynomial. You are
Okay.
intentionally generating those points which are not lying on the polynomial, right? So suppose these are the points. There are several points, millions of points are there we have generated, which are not lying on this polynomial.
Okay.
Now we have some points which are few, right? Maybe 20 or maximum 30 points, right? Are there which are lying on the polynomials, and there are a lot of points which are not lying on the polynomial. So constitute a bigger set consisting of all these points, all of these points. Here, there will be some points in this set. There will be some points which are lying on the polynomial, and there are some points which are not lying on the polynomial.
Okay. Okay.
Now, this set is we are considering as the cipher, you can say. So if this is known to anyone, now what is the aim of the cryptanalyst, person who is not authorized actually, to find out the secret? The person has to find out this polynomial. After finding the polynomial, you may be able to find out the secret. Otherwise, you can't find the secret from this V. Is it clear?
Yes, sir.
So how can you find the secret if V is given to you? You have to construct this polynomial. To construct a polynomial, say of degree 4, if degree is also known, then how many points will be required which are lying on the polynomial? 5 points. Minimum 5 points are required to construct this polynomial of degree 4. So
Okay.
those 5 points must be on the polynomial. If even a single point is not on the polynomial, you can't reconstruct this polynomial. You can construct a polynomial, but that will not be this polynomial. That will be something else actually.
Yes,
So,
sir.
so any other person who is not authorized, it is very hard problem to find out the select 5 points among these trillions of points, right? Which are
Okay.
lying on the polynomial. So the authorized person, what authorized person will do? Authorized person will give the biometrics image again, can find out the minutia points, right?
Yes, sir.
So
Yes,
the
sir.
minutia points may not be exactly those points, but intersection will be there. Some points will definitely be there, which are lying in A also, in
Okay.
the previous impression also. So maybe having the authorized person will definitely be having some of the
Some.
points which are on this one. So can reconstruct the polynomial, right? Others cannot reconstruct the polynomial. Yes, any other doubt?
Sir, one more thing.
Mhm.
While we are constructing this particular polynomial, we have
Mhm.
used this like CRC or any of the codes in constructing the polynomial itself.
Yes, yes, yes,
Um,
correct. Mhm.
so like, is this a correct thing? Like, it's valid to use the CRC to like kind of decode the things. But like using it here itself, is it like um correct thing?
Yes,
Actually,
why not?
what
Okay, okay,
what I
ask me.
am
Yes.
what I was thinking is basically our message is something of importance, like such let's say 4325.
Yeah, this
But
is the original message, this only. Correct.
like
Yeah.
if we
Mhm.
use some other like CRC based thing, the entire entire message gets like okay, okay, fine. I think it's sorted for now for me, sir. Okay, fine. I got it, sir. I got it.
Okay.
So
Any
basically,
other question?
what I was
Yes.
thinking is, are there any choice of polynomials? Like, are there any choice of structure of the polynomial or the curve of the polynomial, uh, according to which we will be having more secure, what we can say, encryption or not? Like, for example, if I form some structure with with the help of polynomial, which is like kind of closed in structure, like
How can you do
it
that? Okay. How can you do that? What is the basic idea here actually? What you have to do? You have to have a polynomial in which the coefficients are the secret basically. It is not in your hand.
Okay.
Right? Whatever the secret is, those will become the coefficients of the polynomial.
Yes.
So it
Yes.
is not in your hand to choose any polynomial, other polynomial. You
Okay.
have to have only that particular polynomial. For each secret, there will be a different polynomial.
But there could be cases, right, sir? Like if we choose a message in such a manner that our this polynomial that we gets generated is kind of closed in nature, or like it follows a
How
particular
can you
top
choose that? No. We are assuming that message is always fixed. Whatever you want to communicate, that is a message.
Okay. Okay.
How can you modify that actually?
Yes. Not exactly modify it. It turns out that we get such a message that we get such a polynomial.
No. Actually, even if you have any specific polynomial,
Okay.
right, that will not make it more secure even, right? Hardly
Yes.
matter, right? So
Yes.
there is no any specific polynomial which can enhance the security. If there
Okay.
is any polynomial, unauthorized person cannot reconstruct this polynomial of degree 4 unless you have at least 5 points lying on the polynomial. If even
Okay.
1 point is not lying on the polynomial, you have got 4 points which are lying on the polynomial, but one is not lying on the polynomial, even then you cannot reconstruct this polynomial.
Okay.
You can have a polynomial which will not be this polynomial.
Okay.
It means
Yes.
indirectly you cannot find the secret in any case.
So, sir, the basically it actually depends upon the message length. The higher the message length is, more difficult it will be to decrypt or decipher from the polynomial.
Actually, you have to see this threshold also. Suppose you are using fingerprint. So as we know that if the person is same, right, then how many minutia points will match? Minimum 9
Okay.
minutia points will definitely match.
Yeah.
More than 9 may or may not match also, right? In general, 9 to 15 minutia points match, right? And if the person is not the same, right, then maximum 6 minutia points may match, right? It means what? You cannot have a polynomial of degree 5. You cannot have a polynomial of degree 6. You have to have a polynomial of degree 8. Then it will be possible in case of fingerprint.
Yes, sir.
Right? So in case of fingerprint, the polynomial has to be of degree 8 because 9 minutia, we know this thing that 9 minutia points always match. Right? If the person is same. This we
Okay.
know statistically, right? So degree of the polynomial has to be 8. Now what can you do? What do you have options actually? Suppose you have this binary sequence and size of this sequence is suppose 128. Then you have to make only 8 chunks, right?
Yes.
You have to have only 8 chunks. You cannot have more than 8. You cannot have less than 8 also. So what will be the size of each of the chunk? This may be variable, right? So depending upon this one, if your size of this is 256, in that case, this will be 32 bit. One of the chunk will be 32 bit, 32 bit, 32 bit, and so on. So in this way, you will be having 8 integers, right?
Okay.
Those 8 integers will become the coefficients of this polynomial. Is
Okay.
it clear?
Fine. Fine, sir.
If suppose it is not exactly 256, then what can you do? You can use padding at the end also. Suppose it is 200, message size is only 200 bits. Then you can use some paddings also, some zeros or ones or whatever you want, right, at the end. And then you can make it exactly of that size, either 256 or say 512 or 128 kind of thing, because that is easy. right, to handle by the system. Any other question? Any other doubt? Yes? No question? Fine, good. So this we have already discussed. So I already explained you these things, that security of this vault is based on the infeasibility of the polynomial reconstruction problem. Now, this is the flow chart or block diagram of this fuzzy vault encoding, because you have to encode means encipher and decipher also. To encipher a secret is what you have to do is you can first form this polynomial E, and these are the error correcting codes of E. So you have to use error correcting code also, as I have shown in the previous example. This one is the CRC. So this is the error correction code. Actual secret is this thing. So after adding this also error correction code, this is the polynomial P. And then what can you do is you can find the points which are lying on the polynomial. It is called the polynomial projection, right? From using the biometrics also. So if you have a point on the biometric, say x1, y1, just concatenate that point, you will get capital X1, and then you can find the value of capital Y1, that is the P of capital X1. So this is called the polynomial projection. And you can generate some sharp points also. The condition for the sharp points is they should not lie on this polynomial. Right? This is the condition. So that's why you have to use this polynomial also to find out the sharp points. How can you do that? Just generate a random number for x, a random number for y also, and check if it is on the polynomial, reject that, otherwise accept that. So in this way, you can have a vault, a set, which is a big set, having the points which are on the polynomial, having the points which are not lying on the polynomial. So this is the fuzzy encoding scheme. Similarly, fuzzy decoding, what you have to do is only vault is given to you and the biometrics is there. This is for the authorized person. So query feature set B, there is the biometrics, and using this biometrics, it is possible for him to search the points which are lying on the polynomial, because this person can also find the x coordinate, and x coordinate, y coordinate, the points are having with this form, x coordinate, y coordinate, and so on. So comparing with the x coordinate, this person can select the points which are on the polynomial. So candidate point identification, it is possible for this person who is the authorized person. Then combination set determination. Then you can combine and you can construct the polynomial. This is the polynomial P dash. So it may not be possible sometimes that the same polynomial has been obtained. So how can you check that? You can find the CRC, check through CRC. If the polynomial is correct, fine. It means you have got the secret. If CRC does not match, it means the polynomial is not correct. It means there was some error while selecting the points. So what can you do is you can choose another set of 9 points. So in this way, it may be required to iterate it, say 4 or 5 times. I think I have seen only 3 or 4 times is sufficient. So in this way, it is possible for a authorized person within few seconds to find out the secret is. Any other question, any doubt? So this is the polynomial P, suppose. These are the red points are the sharp points, and the black points lying on the polynomial are the, you can see the genuine points lying on the polynomial. Now this is the set V. So this V is the cipher, you can say. So we are communicating this V. So cryptanalyst or the interceptor may be having this, this V interceptor may be having. So only V is given then it is not possible unless you have the biometrics to find out this polynomial or to find out the secret. This I already explained. Now, how can you really implement this thing? Let me explain there itself. That will be better. How can you really implement this scheme basically? What you have to do? First, you have to find out this size basically. Suppose it is 16-bit. Because what you have here is you have suppose you have considered that you will be using fingerprint. First, you have to decide that. If you are using fingerprint, then you know that a 9 points are good enough or sufficient to decode or to decipher that. So it means you have to have 8 chunks. So whatever this length of the secret is there, you have to divide into 8 chunks. So this size, there is a size of each of the chunks. It may be 16-bit, it may be 32-bit. Usually we consider only either 16, 32 or 64 kind of thing. The reason I will explain that also. So, but if the size, as I already said, if the size is only 200-bit, secret is only 200-bit, then you can pad using padding scheme and you can have some extra bits also to make it 256 or 512-bit. Now, suppose it is 16-bit. Size is here 16-bit. Then what you have to do? If size is 16-bit, then what you have to do? You have to select a finite field here now. We have already discussed in the class the finite field basically. So the finite field that will be you have to have a Galois field 2 to the power 16. 2 to the power 16 Galois field you have to select. If this string is 128-bit, then this size will be 16-bit. Each chunk will be of size 16-bit. Now you have this finite field. It means these elements, all these values, whatever we have taken say 4, 3, 5, 7, and so on. So in this way, 8 values will be there. Now, all of these are the elements of the Galois field. So how can you do that? We already discussed that for each point, you can find out the point in the, for each integer, you can find out the point in the Galois field also. So corresponding point in the Galois field you have to find out. So it may not be exactly this binary string, you can say, from this one, because this is having the points which are in the binary only. So after having the points in the Galois field, what you have to do is the secret is also there. Secret is this one. So means the points, the coefficients are in the Galois field. So the entire polynomial Px is a polynomial on this Galois field, GF2 to the power 16. Now you have these points, which are the points on the fingerprint. Means minutia points. X1, Y1, X2, Y2, these are the minutia points. So corresponding to this, we have after concatenated, we have got X, capital X1, capital X2. So these also have to be points in this field. So you have to have this size of this X in such a way after quantization or after adding few bits, you have to make its size such that X1 is an element of this field. So X1 is an element of this field, X2 is also element of this field, and Px is a polynomial over this field. So definitely corresponding Y1, whatever you will be getting through Px using this X1 will also be an element of this Galois field GF2 to the power 16. Similarly, this will also be an element of the Galois field GF2 to the power 16. It means indirectly our polynomial is a polynomial over this field, finite field, and all of these points are also elements of the finite field. And then you can construct the volt V, which is consisting all those points which are lying on this polynomial, and some sharp points also. Sharp points will also be elements of this Galois field. So entire all these points are in the Galois field, GF2 to the power 16. Right? Is it clear now? And then you can use decoding also, whatever as we have discussed in the previous slides. Yeah, if you have any question, any doubt, you can ask me. I already explained you everything.
Sir, regarding matching between the biometric patterns, uh, we do not have any particular one-to-one correspondence in this case. Like if I extract at the sender's end and then I try to match the patterns at the receiver's end, I do not have like a particular like one-to-one correspondence between A and B. And even if there is like a small difference of zero point 0.5, like if the abscissa is just shifted by 0.5, they'll not be considered as one.
Okay, what you have
So
to do is,
in
I
this
got the
case,
point.
yeah,
Yeah,
false rejection rate will be very high then.
okay, okay. Now, after finding the X value and Y value of the Misha points, definitely quantization is required. If you have used the quantization, right,
Okay.
with A, finding set A and finding set B, then definitely at least 9 points will definitely match.
If
This we
there's
have
a
discussed in
particularly
here also.
registered, uh,
And
like if
some
like
noise may be there, some variation may be there, definitely, you are right. Because then we are quantizing. What is the meaning of that actually? 3-bit quantization you are using, suppose, or 2-bit quantization. I think 2-bit is sufficient,
okay.
right? Only that much variation is possible. Not more than that will be there.
So what if the orientation of the points are completely different?
Oh, no,
That
no,
is
that alignment you have to do. Suppose you have this fingerprint. After that, you will be having this fingerprint.
yes,
It
but
may be like this.
that
No?
uh,
So definitely you have to find out this as x-axis. Here, this will be x-axis. I have already discussed in the class also. This is the
okay,
y-axis. You have to
okay,
find out the score point, and you
okay.
have
So
to find
basically,
out this direction also through
yeah.
line of regression. Right? We
And
have discussed in the
do we know in the vault which of the at the receiver's end? Do we know when we get the vault? Do we know which of the points are actually belonging to the biometric pattern and which are the points not belonging to the biometric pattern,
okay,
which are
okay,
sharp points?
okay, okay. Now, when you have received the vault and you are the genuine person, same person, now
Yes.
you will be finding these points, your own Nusha points.
Hmm.
So suppose x1, y1, x2, y2, and x3, y3. Definitely, all the points will not match with the earlier impression, right?
Yes. Yes.
But at least as we know that, at least 9 points will definitely match. Now, if you have got, say, x1 dash, y1 dash, this is the new Misha point. This
Yes,
was
sir.
the which whatever you have used actually. Then x2 dash, y2 dash, and so on. So you can find x1 dash, you can find x2 dash, and so on. In this way, you can find all these things.
Okay, sir.
Now, out of these x1, x2, xn, you have many such points, say 20, x1 dash, x2 dash, x3 dash, and so on.
Yes.
Out of these 20, we know that at least 9, maybe 10 or even 15 may match actually with these x values.
Yes, sir. That is fine.
We know that. That is correct now. So now in this world, the points are like this: x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate, like this thing only. So now what can you do is you can see this x1 is there as x coordinate in anywhere. Fine.
Yes.
If it
Yes.
is there, suppose with this one, the same x, this x value is there with x coordinate, it means this is the point which is on the polynomial. This is a genuine point, right?
But sir, this step can be done like one-to-one matching can be done once we have aligned the biometrics.
Definitely, that is essentially required. Otherwise, even recognition is also not possible. In
So
fingerprint recognition, that also requires this alignment.
if I
Alignment you
know
have to do.
if I know the points in the vault which actually belongs to biometrics, then in some sense I know which of the points actually belong to the polynomial.
Yes,
Because
that's why.
biometric
Yes, yes.
and from it's feasible to kind of fit the curve even approximately, but it's possible to fit the curve polynomial p. So in that sense, we might be able to recover the secret itself, sir.
Who can recover the secret?
At like at the receiver's
Third
end,
person.
for
Can third
example,
person
if I
recover?
get
Okay, can. Hmm. Any third person can find out these points? Is it possible for him or her? If the same biometrics is there, it means if the intersection between A and B is more than threshold,
okay,
only then you can find out the sufficient number of points which are lying on
yes,
the polynomial.
yes, sir, yes, sir.
Other person, is it possible for other person also?
No,
Because
sir.
other person. Mhm,
What I am claiming is, if we
mhm.
know x, the points that actually belongs to the biometrics in the set V,
May know. Who may know
yes,
this thing?
at the receiver's end, because if
Receiver
receiver
means
will,
genuine receiver. Receiver means genuine person. No?
it can be genuine, it can be an imposter.
Imposter cannot find out these points which are on the polynomial y because imposter may not be having all those minutia points.
Okay, so
These points, how are you finding these values? Only through the minutia points. If the
yes,
same person is there, only then it may be possible. If person is different, minutia points will be different.
but yes, but even to find out these particular minutia points which are actually aligning with the person's biometrics, we must perform one-to-one correspondence, like one-to-one matching of the points. We have to align them.
One-to-one matching means what? The third person, what can he do? Okay, let me discuss that. The third person has to have 9 points, right?
Sorry.
Suppose here there are trillions of points.
Okay.
Now you have to choose 9 points. If you are randomly selecting 9 points, say, right?
Hmm.
So how many ways will be there? How hard that problem is?
I agree, sir. Like it's like matching 9 points out of trillion points. Agreed, sir.
Yeah, yeah.
Fine. What
Okay.
I am thinking is, I'll try to explain it more clearly this time. So
Mhm.
we get a vault. Okay.
Okay.
Now, in the vault, we have to first see if for person A generated a vault and sent it to person B. Let's consider person B may or may not be it may person B might be a genuine user, B might be a imposter user. Let's consider this for now. So
Okay.
now, in order to person B to get authenticated, biometric patterns of A and biometric pattern of person B must be aligned. Now, biometric patterns of A are present in the set V. So, to align these two features, we must at least know which of the points are actually the biometric points in the set V of person A.
Yes.
But in that sense, if I consider, like, if I find out, like, if I came to know that the first 20 points of the set V of the vault belongs to biometric patterns of person A.
No, no, no. You have to scramble after that.
Yes,
The
that's what I'm
the
suggesting.
points
We
which
have to
are no,
scramble.
scramble is, yeah, definitely, definitely. This it is not like that. The first 20 points are lying on the polynomial. Then everyone can decode that.
Yes, yes, everyone
No,
can
no,
decode it, but
scrambles, scrambles. All of
yes,
these
they
points
have
are
to be scrambled.
scrambled out. Yeah, yeah, scramble.
Agreed, sir, agreed.
Yeah.
But in order to align these two features, A and B is biometric. उन दोनों का biometric अगर मतलब अगर हमें align करने का है, then we must know which of the features are actually present in A. मतलब A के कौन से biometric patterns है. Then we'll be
No,
able
no,
to align them.
actually, alignment means what? Alignment means this thing. So if you have fingerprint, given fingerprint first time in this way, and second time, suppose
Yes.
this is your fingerprint, right? Now you have to find out X and Y values for this fingerprint at the beginning. During encoding,
Yes.
you have used this one. During decoding, you are using this fingerprint impression. Again, you are after aligning, you have got this as x-axis. Earlier, you were having this as x-axis. This is the new y-axis. This was the y-axis earlier. So the coordinates will remain same of the minutia points, right? After aligning,
Coordinates after
yes,
aligning, right, sir?
yes,
But before
definitely. That
aligning,
is no. Definitely, you have to align the
but at the
fingerprint,
B
even
side.
for matching also. Suppose this is
Yes.
impression. First time you have given this impression, second time you have given impression. I'm assuming that the same person is there, right?
Okay.
A is the impression of the person Alice, and B is also the fingerprint impression of Alice only, right?
Okay.
It means definitely 9 points will match. If this impression is not of Alice, but it is impression of someone else, say Bob, then then the minutia points, the coordinates of the minutia points here and the coordinates of the minutia point here will not match, right?
Yes. Agreed, sir. Agreed.
So if this is Bob and this is Alice, then Bob may not find out the points, those points here, which are on the polynomial from this world actually. So
Okay.
Bob will not be able to find out the points because these are scrambled points. Has to search where this point is. It is very difficult because what Bob can do, Bob can find out the minutia points of his own biometrics, right?
Yes.
Because Bob
Yes.
doesn't have the biometrics of A.
Yes. Yes, sir.
So will not be able to find out the points which are really lying on this polynomial,
Okay.
right? From this set,
Okay. Okay, sir. Okay, sir.
right? So that's why it is a hard problem.
Okay.
In every cryptographic system, I'm not saying decryption is impossible or analysis is impossible. Analysis is possible in every crypto system. Maybe AES, DES, or stream cipher based crypto system or any asymmetric crypto system. Analysis is definitely possible, but the time requirement is, say, in terms of years, you can say. It is a hard problem, right?
Sir, so
So
instead,
similarly,
can we do some
mm, yes,
can we do something like this, that we consider a universal template. Let's say we consider a universal template. So we find that, for example, we have to align A and B. Like here, what you have mentioned, A, the first fingerprint, and the rotated fingerprint, A and B, if you have to align it.
yes,
But we
yeah.
do not want to exactly reveal A's coordinates. Let's say. So can we consider a universal template, which is like kind of agreed by everyone, that whenever you send me a template, I'll first align my biometrics to that universal template. And once I align my biometrics to the universal template, then I can perform one-to-one correspondence matching.
No. If actually, if your biometrics is different, coordinates have to be
Yes.
different. Points have to be different points,
Yes.
right?
Yes, sir. Yes, sir.
Then you have to align actually. What is a universal template actually in this case? Because you can rotate, you can translate your fingerprint also. Some translation may be there, some rotation may also be there, right?
Yes, sir.
So it depends person to person, vary person to person also, right?
Yes,
So
sir. Yes.
what can you do extra is, as it is discussed in the class also, even I think last class, cancelable biometrics number has also explained, and in some of the presentations also you have seen that cancellation is also
Yes.
possible. It means along with this biometrics, you can have something else also, right? And you can combine that with the biometrics to find out the cancelable kind of feature set.
Okay. Okay.
That is possible, right?
Okay.
So the importance of that cancelable kind of thing is, whenever suppose you have lost your something, you can modify,
Yes.
you can change that easily.
Yes. Agreed,
So
sir.
here also you can use cancelable, and then you can find out these points x1, y1, x2, 1, x2, and so on.
Okay.
That is also
Okay.
possible.
Okay.
Any other question?
Actually, I was querying so much about this because in the assignment 3 we had to align in the transductive SVM part, we had to do alignment between the like we have to match two fingerprints. In that
Yeah,
case, without exact one-to-one correspondence, the performance was actually coming severely low. So
it
I
will
saw it
low, definitely.
practically. Yeah. So practically
So
it
what
was
you have
not
to do
visible.
is, no, no, no.
Yeah.
What you have to do is for exact matching, what you have to do is first alignment and then
Yes.
quantization.
Yes. Alignment then
Without
quantization.
quantization, it will not match it. Yeah.
Yeah. Yeah. Perfect.
If you will use 3-bit quantization, it will definitely match.
Yes, sir. Yes, sir. Thank
Yeah.
you.
Okay. Any other question or any other doubt? Okay. No question. So we have completed this one also now. Means how can you use this biometrics in cryptographic systems? So this can be used in communication also, secure communication, or it can be used in for key management also. Suppose you have a key, 128-bit key. So for that key, what can do is similarly you can have this polynomial and you can create vault also using your own biometrics, and vault can be stored somewhere in your system. So if suppose any other person has got this vault, even then will not be able to find out the polynomial, or indirectly will not be able to find out the key actually. So who can find out the key? Only you, because you have your biometrics. If you will give again your biometrics, you can again find out these values x1 dash, x2 dash, and so on. And you can select the points from the vault and you can reconstruct the polynomial. Or indirectly, you can find out the key. So this can be used for the key management and as a crypto system also. So now Amber will continue that. Amber, you can, okay, I'm giving you the access for that. Let me give. Amber, do you hear me? Amber, hello? Amber is not there. Amber?
Yes, so much. Yeah, now it's working fine. Yeah, I'm there. I'm here only.
Okay, good. So now you can upload your presentation, give the things you wanted to discuss today.
Sir, I'll upload today. I'll discuss multimodal. Start with the multimodal.
Yeah, just upload that.
So will there be class tomorrow?
Yes,
Okay.
definitely.
Same time.
And second thing is one announcement. Uh, sorry. Yeah. Do you hear me? Am I audible
Sure,
now?
you're right. Yes,
Yes,
yes.
correct. So regarding this NTEM exam, now what I think is there may be option. I can give you the option. I don't have any problem. Maybe open notes as it was there in the midterm also, or maybe closed notes also. What I feel is in the midterm exam, I found that maximum, I think only 54 or 56 was there, maximum score. So I don't want that thing. So if again we will be having this pattern, means open notes, then again I have to set hard problems, and if you will not get good marks, then it will be difficult for me to give good grades also. So that's why my advice is this time, if you want, you can have closed notes and closed books. So that questions will be slightly simple. So all of you will be able to at least attempt a few questions, means at least 50% marks should be there with everyone. This is what I want actually. Now I'm leaving to you. If you want open notes, then you can have that also, or closed notes. Yeah. Any comment? Yes. Yeah. Am I audible? Yes.
So I would say let's have open notes. Frank, I'll be frank at this point. Um, the previous question paper that you said, although we have not scored very well in the
Yeah.
examination, but
Yes.
it was doable.
Yeah, definitely it will be doable. But if you cannot score well, then actually I don't want that, right?
Yes.
And average was also low,
Okay.
not only the maximum one. So I want the average should not be less than say 50, 60%. It should be more than that even, right?
It's just that sitting in, like, because there is so much of content and it requires so much of like kind of remembrance of like a galva field and like many other things which will be coming in the
I think
examination.
it will be better for you also. And it will be better if you will read carefully. It will be good for you in future also,
Yes, it will be,
right?
of course it will be better,
You
sir.
have to, yeah. So if
But
you will
it's
read
just
carefully
that
and if you will solve some of the problems by your own, then there will no need, no need to remember those things actually.
yes, I agree, sir, I
Yes.
agree. It's just that it's
Practice, only practice is
just
required. That's all. Just practice. If you will solve
previously,
one
like
or two
personally,
problems,
I had the mindset that we'll be having open book. Okay. So
okay,
I have
others,
fine-tuned my preparation with respect to open set, I would say.
okay, what about others? Yes.
Hello, sir. So
Yes,
I agree with Aman because there's a lot of content that we need to cover for the majors.
not covered.
No, sir,
What is that?
you have covered a lot of syllabus, so having open notes is kind of beneficial for us.
So you want open notes only? Huh?
Yes, sir.
Okay. All are happy with open notes. I don't have any problem actually. If something is there, if you don't want, you can write the mail to me. Then we can decide. So, but you have to send today only because tomorrow I will announce that the decision, right? Whether it will be open notes or closed notes. Open book is not possible, right? Because otherwise the students may bring a lot of books and kind of things. So it is not possible. Only open notes should be.
Sir, today are you will be in an office or basically I have to check the mistakes of the minor exam which I made.
Yeah, yeah. Earlier, in previous class, I brought that. So what can I do is maybe on Saturday you will get.
Okay, it's Saturday timing.
Saturday I will tell you.
Okay, miss. Okay, thank you, sir. Means basically before the minor, just want to know mistakes over
Yeah,
that.
sure, sure, sure.
Thank you, sir.
I think you do you know the Mars? Have
Yes,
you
sir. I
seen
know
your
the mark.
Mars? Okay,
Yes, sir.
okay, okay. I will show you the answer sheet also.
Thank
Saturday.
you, sir.
Wait up. Yeah. Anything else? Okay, Amber. Now you can continue, man.
Okay, sir. So today we'll be discussing the multi-biometric systems. These are the systems which are having either the multiple instances of the different traits or the multiple traits are being used. So so first we'll discuss issues in unimodal systems. What is the need of having them? Am I audible to all of you? Hello?
Yes, Amber, you are audible.
So, okay, it's fine, it's fine. So first we'll discuss the issues in the unimodal systems. First one is the noisy data. So if fingerprint image comes with a scar or there is a dirt on the sensor, let's say, so this will not be captured correctly. Or for example, the voice can be altered by cold or the pure. Po- Hello, or the poor illumination of face. So because of this noisy data, genuine user may be rejected. So it's better if we could have more than one biometrics. Next issue is the inter-class variation. So it's caused by individual who is incorrectly interacting with the sensor. For example, incorrect facial pose or change in the biometric characteristics or change in hand geometry. So, so these variations can be handled if we have this what's called stored multiple templates for every user and update it over time. Next issue which comes is the interclass similarity. It is the similarity of different what's called different classes or different individuals are having similar characteristics, similarities between them. So this increases the false match rate. So we have to set some upper bound on what's called these number of fixed features that has to be there, which could be which could be matched for you, which could be what's called matched for using a particular algorithm. Another issue is non-universality. It defines that biometric may not be able to acquire meaningful data from subset of users. For example, fingerprint system may extract incorrect minutia features because of poor quality of ridges or the lines which are there. So failure to enroll rate will be there. Another issue is interoperability issue. So this defines that mm, some biometric most biometric they operate under the assumption that biometric data we compared are obtained using same sensors and hence are restricting the ability to match or compare originating from different sensors. For example, speaker recognition finds it difficult to compare voice prints which are originated from two different technologies using two different devices. So in such cases, extraction and matching algorithms that will be that will work across different sensors are required. And the issue is spoofing, which we have discussed previously also. Uh, so this involves manipulation of one's biometric in order to avoid recognition. Spoofing the fingerprint, iris, and face we have seen. So these are the different issues which are there in the unimodal systems, and because of these issues, we need multimodal systems. Another one is the next is the source of multiple evidence. So multimodal systems utilize information from these multiple sources. The first one is minutia representations. For example, if we are talking about fingerprint trait, let's say, so here you can see the different types of features in the minutia. One is they have taken texture, another one they have taken minutia. So for the same trait, fingerprint is there, but multiple representations are there. Next one is the multiple instance. In the multiple instance, you can see there are two eyes, left eye and the right eye. So eye or the iris is the feature and the different instances of iris are there. Then in multiple samples, there are multiple samples of the same user will be there. For example, fingerprint, multiple sensors, the data has been taken from multiple sensors. And the last one is multiple biometric, which is the more common one. Here many biometric traits will be used. So in all these except multiple biometrics, they are derived from single trait, as we can see. And the last one, the multiple biometric, it has got multiple traits. So if we talk about the Aadhaar system, so in the Aadhaar, you must when you all must have enrolled. So you have seen that you have to use all your 10 fingers and your two iris. irises are being used, irides. So it is both multi-stance and multi-model. So you can see it is a hybrid multi-biometric system. Now we'll discuss each one of these. First one is the multi-algorithm system. In the multi-algorithm system one, same data is being processed and stored using multiple algorithms. In this example, the same fingerprint has been taken, and the fingerprint in the first one, the first image, the features are the minutia points which are being extracted, and the algorithm will be working on the minutia point features to do the matching part. Let's say another one is a texture base. It will find out the skin texture, and the algorithm will work as per the this texture feature to do the matching. So in this particular case, no new sensor is required because we are having the same trade, same what's called trade fingerprint is being used. So in both the cases, in these two, uh, the same data you require, which is the fingerprint, but we are extracting different forms of features. So matching algorithm will be different, but or extraction algorithm will be different, but the new sensor will not be required. So the cost is less for this particular systems, multi systems. Also, the different sources of evidence obtained from same raw data, right? Yes, the same data, from the same data only you have got both minutia as well as texture. With this in this image in a graph, they have shown when they have used these are the two algorithms, NEC and Cogent. So when using one algorithm, this is the false match rate on the dotted line, or using another algorithm, the another dotted line is the false match rate, and when they combine these two, this is the false match rate. So using this course for the true match rate and the this course of the true match rate or the genuine rate which we call, and the false match rate has been shown. So we can see that with the help of when we are using multi-one systems, there's a higher chance of the false match rate will be reduced, and your system will be more accurate as compared to the one which having single algorithm. Next one is the multi-stance systems. In a multi-stance system, the same multiple instance of the same biometric will be taken. So here you can see the biometric. Here is the fingerprint. So they have taken the 10 fingerprints are being taken. So the same sensor will be required. The same sensor can take all the 10 fingerprints. So no extra cost will be, only the cost of sensor will be required because you need all these multiple sensors. But this cost will be incurred, and these systems they are easy to implement because you don't have to have any only you have same data will be required. So you can just extend those data. No new feature extraction algorithm is required, no new sensor is required here, no new matching algorithm is required here. So this is easy to implement, and it is beneficial for users whose biometrics cannot be reliably captured. For example, sometime it happens that for users with if they are getting authenticated with the help of the single finger. So a person will be having dry finger skin when the skin is dry. So it is sometimes difficult to get authenticated by the system. So if you are using multiple instances, so they have a high chance of getting authenticated by the system, like drooping eyelids as an example. So this is how multi-stand system works. Another one is multi-sample systems. So in the multi-sample systems, a single sensor is used to get multiple sensors samples of the same biometric trait. For example, if you talk about fingerprint, you must have seen in the FVC database when you have done your assignment. So there are 8 samples for every single fingerprint. So this is known as a multi-sample system. When you have taken only one trait is there, but multiple samples are taken. Also, if you take face as a trait, so you can have the front image of the face, left image, right image, back image. No, not the back, left, right, and front. So this is the multi-sample system for the face system. And the key issue is multi-sample is, for example, determining the number of samples and need to be required for a trait. Samples should represent, there has to be some variability among the samples, and having multiple samples increases the chance of this reduces the false match rate and increases the accuracy of the system. Next one is the multi-sensor systems. A multi-sensor system is the one which is from the name itself, it's clear it requires multiple sensors. Sorry, so multiple sensors are required to capture the data. So since multiple sensors are required, so cost will be high, and also the matching accuracy will be high because you have different formats of the data. For example, hey, we can system can record two-dimensional face of a person using CCD, charge coupled device camera will be required. So you can have 2D image, and you can have the 3D image using another sensor, right? So increasing the sensors, cost will increase, matching accuracy will also increase. Next one is the multi-model systems, which is a more common system, and which is highly used. So multi-model systems are the one which are having combined everything, this having multiple traits. Different traits are being, for example, face and voice, two traits they have used. So, and they have high performance as compared to all other multi-value system because you are using different traits. So chances of matching this increases. Also, the cost will be higher because you are using different types of traits. So for them, you require different sensors as well. So the cost is high. And definition accuracy can be improved by increasing number of traits. By increasing the number of traits, you can increase the accuracy, but it has to be, you have to see how much when you are increasing the trait, how much effect is creating a system. I mean, what is the cost? What is the enrollment time? The time should not be more. What is the throughput? What is the error rate? Habituation issues, whether user are habituated to it or not. So if you ask somebody to give a, let's say, what is this called, palm toe, for example, if the toe is also a biometric trade, if you ask somebody to give the sample of toe, so people are not always comfortable to remove the shoes and the socks and give you the sample, toe sample, as authentication. So this has to be habituated also to the user, whatever trade you are being used in your system. So next we'll discuss the acquisition and processing architecture. Acquisition defines the order in which you'll acquire the different traits from the individual. So this is of two types, either serial or parallel. In the serial acquisition, each source is independently obtained with a body or is stored, or you can say each and every biometric trait is independently obtained. So there is increased enrollment and authentication times and lower installation cost because once you have taken one trade, it is enrolled, and then you go to another one and so on. So installation cost will be low. And the parallel one, evidence of the trade is required simultaneously. For example, when we authenticate this face, so we can have the sensor in which it is capturing the iris information also along with the face information. So this increases the cost. So high cost will be there. Also the enrollment time or the authentication time will be less because the same device having in-house what is called sensors. So enrollment time will be less and the authentication time also will be less. Now, this is the example for this processing sequence in the parallel mode and sequential mode. So the first one is the sequential mode. The fingerprint as a trade comes. This fingerprint is authenticating system. So now the system will ask, is additional private data required? If it is not required, then go to the matching algorithm and find out whether this is a match or not, determine identity. And if the additional information is required, then we'll go to another trade, whatever trade is required, that will be captured. For example, face will be required, face will be captured, then these two are captured, fingerprint and face. Now is other additional information required. If it is not required, work on these two algorithms, fingerprint face, and find out the identity. If the additional information is required, then go to another trade which is to be capture, for example, here hand geometry, get the trade, and find out the identity of the person. Now, similarly for the parallel ones, in the parallel ones, all the traits will come all together. For example, fingerprint, face, hand geometry. So you have to have the sensor which can capture at once these what's called now all the traits simultaneously. You can for hand geometry we can have different sensor, or for these two fingerprint face one sensor will be required, and which can uh, no, one for fingerprint and hand geometry, another one for the face. It will be captured, and then this all the data will go directly to the matching part to find out the identity. So these are the two different ways in which we can acquire the biometric data. in the serial mode or in the parallel mode. Next one is the fusion levels. Fusion defines how we will combine all the data. So in the fusion level, the amount of information which is available to the system it get reduced when you proceed further in a system. So at the starting, for example, if we talk about fingerprint, so when you take the fingerprint image, it is like here it is given as from 42 kilobytes of data will be there. Then you will extract the features from this image. After extracting features, my all the minutia will be extracted. Once the minutia are extracted, it reduces to 112 bytes, for example. So it is reduced from 142 112 bytes. Now when this is passed to a matching module or the matching algorithm, so this again the this algorithm will give you the match score. Match score will be a 1 byte number will be there ranging from 0 to 100 how much matches there. So now this 112 byte is reduced to 1 byte. Now further it will pass to the decision module or the decision algorithm which will find out whether it is a match or a non-match. If it so this is again a 1 bit 0 or 1 match or non-match. So this fusion levels with the amount of information keeps on reducing as it passes from the where you're capturing the data, the sensor at the end when you are giving the decision. So these are the four different ways. Before matching, the fusion can be at sensor level and feature level, and after matching, the fusion can be at score level, rank level, and decision level. So the most common one are the score level and the feature level. So we'll go one by one to each one of these. First one is the sensor level fusion. In the sensor level fusion, the fusion will be at the sensor. So this requires combining evidence or the fingerprint, if you talk about fingerprint, present by multiple source of data before we go to feature extraction. So before you go to feature, for example, here we'll before going to feature extraction, we'll take all the samples, combine them, and so that you can have good amount of features. Okay. So here we have in the image you can see fingerprint sample A will be there, fingerprint sample B is there, but these two samples are somewhat incomplete. You can say the other one, the upper one is showing the lower part of the fingerprint, and the lower one is showing the upper part of the fingerprint. So we need to combine these two. What's called these two samples. So combining these samples to get a good amount of information is known as mosaicing. So here in the fingerprint mosaicing, these two samples are combined at the sensor itself to get a mosaic fingerprint, and this from the mosaic fingerprint, which is the almost complete fingerprint, as these two sample A and B are seems to be incomplete fingerprint. So after you get the mosaic fingerprint, you will extract the features. The minor features are extracted, then the score will be found out. This is a later part. Okay, so here in the image above, in the what is called flow chart above, it is given enrollment samples will be there. BE, is the enrollment time. You take multiple samples, B1 to BM, total number of AM samples of a user. Then at sensor level, the function F will be used to fused. Function F is doing the mosaicing. Mosaiced, all the images are mosaiced for a particular sample. If it is in those are incompleted images, and then features will be extracted, and then it will be passed for the two matcher module decision and so on. Similarly, authentication time, multiple samples will be taken and there will be at sensor level will be mosaic combined together, and then you will find out this what's called fuse them and it will pass to each extract and so on. Next one is the feature level fusion. In the feature level fusion, features are or representation of level fusion involves combining the features. Here the features will be combined. So here you can say, see the environment samples will come. So we will have different feature extraction algorithms. Let's say feature x1, feature x2, and those different algorithm will give you different set of features. All these set of features are x1 to xm. The different features x is equal to x1 to xm. So in the feature level fusion module, this function f will combine all these features into a single feature set. So xf is a single feature set. Now once you get a single feature set, this will be passed to the matching part. Similarly, during authentication also, the different matching algorithm will be there. Feature extractor algorithm, not the matching algorithm. Different algorithm for extracting features. All the features will be extracted and then they are combined together, given to the fusion module, and then this go to the matching part. So this feature line fusion is divided into parts: homogeneous and heterogeneous. In homogeneous fusion scheme is used when the feature sets are obtained from like same feature extraction algorithm has been avoided. For example, you have one trait, let's say fingerprint. So you have taken minutia of one and another one also minutia also only. So this is same. So homogeneous feature is sorry scheme will be required. Another one is heterogeneous fusion scheme. In this, that when the components are from different algorithms or from the different traits, also we can see. So they are different. They are having different representation. So this is known as the heterogeneous feature fusion techniques. So first one is the homogeneous feature fusion. Do we have time left? Hello,
No, ma'am, time is done.
sir is there? Oh, sir is
No.
left. So I might need another lecture for this. Tomorrow, sir is covering anything in class?
Sir hasn't kind of earlier told like what he'll be covering, but I guess there'll be some time left even after sir's lecture.
Okay, fine. So then I'll cover the remaining part maybe tomorrow, because this will not complete today. It's a big topic.
That is fine.
Any
Ma'am, just one thing.
any
Can you
doubt?
please
Yeah,
uh, can you upload the previous PPTs as well as this one on the
I
Google?
previous I've uploaded already. This one I'll upload when I'll finish this one. This topic, then I'll
Okay.
upload it.
Okay. Okay. Thank you.
Okay. Any other doubt? Hello. Any other doubt? Okay, then thank you. We'll continue this tomorrow, maybe. Possibly tomorrow we'll continue this. Okay, thank you.